Hey everybody. Okay, in this video we're going to take a look at parallel lines, and there'll be another video about perpendicular lines. And if you watch the one about writing equations of lines, then you're already ahead a little bit on this stuff. Okay, so let's get to work. If you're taking notes, obviously you might have to pause the video and write some stuff down. Okay, so when we start thinking about this parallel and perpendicular line thing, I think it's important to see it graphically first. You know, we could say really quick that parallel lines have the same slopes. Well, that's a fact. They have to. But I think looking at a graph would help us visualize this. And I've created a graph here so we can kind of wrap our head around what they're saying. And if you see the slope of this line, I'm going to say M1 and M2. Well, that's just saying they're different. They're different equations of lines, but they have to have the same slope, or they'll intersect somewhere. This guy has a slope of over 1 up 2, so he's got a slope of 2, and so does this one, and these will never intersect. That's why they're parallel. Okay. So there's a couple of problems they're going to ask us to do with respect to this parallel and perpendicular idea. Okay, or parallel especially. And here's our first one. All right, example 1 says, find the slope of the line parallel to this line. Now, the problem here is this slope can't readily be seen in this form. And for you guys that remember this stuff, this is in standard form. So we're going to need to work on it a little bit here. So I need to take that equation that's in standard form and just move some things around and write it in slope-intercept form. So we're given x plus 3y is negative 12. We need this form right here. Because if I know what the slope is, I know my line has to have the same slope. All right, so I'm going to begin by subtracting x to the other side. Right? And we get that 3y is equal to negative x minus 12. And now we're just left with dividing by 3. And negative 1 is the coefficient of x here, because I'm going to call it negative 1/3 x. Now I've still got my negative 12 divided by 3, which is going to become a 4. Right, negative 4. All right, so the question was, a line parallel to this one would have to have a slope of negative 1/3 because they have to be the same. So that's one question. You're going to see some of those in Delta Math. And there's a more difficult question too. So I'm going to keep this video going until we do one more example. And maybe we might have time to summarize a little bit too. Let's see. All right, so that one says, find the slope of a line parallel to this. All you do is find the slope, put it in mx plus b form, and you can identify the slope and just report it to the problem. All right, example 2. What is an equation of a line that passes through this point and parallel to this line? Well, so the problem here is, in the first video I did where we wrote an equation of a line, that this is that problem with an additional layer of not knowing the slope of this line. So really we need to go into work here, solve this thing for a slope, and then just write an equation of a line through that point. Okay, so the very first move here is just like the last problem, where we need to find the slope first before we can do anything. And we're given, and it's equal to, say, 10. All right, so again, now I'm going to work a little quicker with this. I'm going to move that x over. Remember, we can just change the sign and move it right over. That's what's going to happen anyway. And now I'm going to divide by that 5. Call that negative 1/5. And the 10 divided by 5 gives me a 2. So my slope here is negative 1/5. Now I'm told to go through the point. What is the point? What is that point? I can't see it. It's negative 5/7. Okay. I'm told to go through the point negative 5/7. All right. So to do that, we'll have to write, just like the last video, we're going to substitute 7 for y. There's my slope coming in. We're going to put that -5 in here. And we don't know what b is, right? That's the whole problem. So now we have 7 equals -1/5 times -5 is 1 plus b. So it looks like b is going to have to be 6 when you subtract that 1 over, right? All right, so our answer to this problem is y equals -1/5 x plus 6. All right, let's see that that's what we wanted. Now, we have an equation that goes through this point, like they told us it had to do, and it has to be parallel to this one, and it is because we used the slope of that line to do it, the same slope. And our M1 is equal to our M2, so you could say, well, this is my M1, and here's my M2, and they're exactly the same. All right. Next, we're going to work on some perpendicular lines. There's a little bit trickier, but not much. And thanks for watching. And we'll get to this next example 3 and 4, and we'll be wrapping this thing up. Now, we're going to use this a whole lot more in our geometry than just writing equations of lines. But this is one of the first things we have to be able to do. Okay? All right. See you in the next video.